This presentation will explain how to interpret the behavior of a function from looking at the graphs of its first and second derivatives. You can look at the graph of the first derivative of a function and determine where the function is increasing and decreasing, as well as where the critical points occur. A positive first derivative means that the function is increasing. A negative first derivative means that the function is decreasing. This graph shows the function f of x is equal to sine of x in the red solid line, and its derivative f prime of x is equal to cosine of x in the blue dashed line. You can see that on the x values where the first derivative is negative, that the function is decreasing. And you can see on the x values where the first derivative is positive, that the graph of the function is increasing. Critical points occur at any point where the first derivative is equal to 0. Continuing with our example from before, we have the graph of the derivative f prime of x equals cosine of x. You can see that there are points where f prime of x is equal to 0, like here and here, and these are going to be your critical points. The graph of the second derivative can be interpreted to determine where the relative minima and maxima occur, where the inflection points occur, and where the function is concave up or concave down. When you plug the critical points into the second derivative formula, you will get a positive value where the function has a relative minimum, and you will get a negative value where the function has a relative maximum. Continuing with our example from before, we have the graph of the second derivative, f double prime of x is equal to negative sine of x. At the critical point pi over 2, right here, the second derivative has a negative value. This means that the function has a relative maximum here. At the critical point 3 pi over 2, right here, the second derivative has a positive value. This means that the function will have a relative minimum here. An inflection point is a change in the curvature of the graph. So this can be going from concave up to concave down, or going from concave down to concave up. Inflection points occur where the second derivative is equal to 0. On this graph, you can see an inflection point right here at pi. A positive second derivative means that the function is concave up. A negative second derivative means the function is concave down. On this second derivative graph, you can see that the second derivative is negative from 0 to pi. This means that the function is concave down on this interval. The second derivative is positive from pi to 2 pi, which means that the function is concave up on this interval. And here's a table to summarize what you just learned in the previous slides. In this column, it includes the different behaviors of the function f of x, and in these two columns, it includes what the sign should be for f prime of x and f double prime of x. Thanks for watching.